In this episode, we're completing the replacement of the timing belt, power steering, and accessory belts, the clutch master and slave cylinders, the brake master cylinder and brake booster, along with reinstalling a rebuilt alternator, a new front motor mount, and a rusted out subframe cross member. And then we'll install a new radiator with hoses, a new thermostat, a starter motor, and replace the AC condenser, accumulator, and AC hoses. We start by installing the engine side motor mount bracket and lowering the engine to install the lower timing belt cover. With the lower cover on, we torque down the side motor mount bolts, which was followed by the alternator bracket. The upper timing belt cover can now be installed. After the harmonic balancer was installed, we installed the power steering belt tensioner assembly and the alternator and AC belt tensioner assembly. The belt installation sequence starts with the power steering pump. Tension is applied to the belt using the end of a 1/2-inch wrench positioned between the ears of the tensioner bracket. Applying clockwise torque to the wrench, the protruding nut to the right of the wrench was tightened to lock the belt tension in place. Afterwards, the power steering pump pulley bearing bolt was torqued down. Now comes the alternator and AC accessory belt. After the belt was mounted, the belt tension was adjusted through the vertical adjustment bolt behind the pulley bearing. The belt tension was locked in place by torquing down the pulley bearing bolt. With the new clutch master cylinder fitted against the firewall, we attach the clutch piston rod to the clutch pedal and secure the master cylinder to the firewall. We did this by installing the 2 nuts on the master cylinder's bolt stud. Before installing the brake booster, we torqued down the flare nut connecting the clutch line to the master cylinder. When we removed the old clutch master cylinder, we had to cut the hydraulic lines because the flare nut was rusted in place. We then had to fabricate a new line and use compression fittings to secure the new line. We show this process in this video link here. The brake booster was in good shape and didn't require replacement. We then mounted the booster back onto the firewall. The booster's piston rod was reattached to the brake pedal and the 4 nuts installed and torqued onto the booster's mounting studs.
This is the old master cylinder we removed from the Mitsubishi. It was leaking through this back seal. You could see all this corrosion. We got a new refurbished master cylinder. I have to still transfer the master cylinder reservoir from the old to the new. This is pressed into these 2 seals over here. So when you're in the process of removing it, you don't want to pull it on an angle because you run the risk of potentially breaking this part of the plastic. So the first thing you do before you remove the reservoir is to take this screw, which is recessed inside this mounting point here. Take this screw out and then pull the whole reservoir container. We'll just put a very light coat of dielectric grease to help it slide in. There we go. We're going to fill this up with brake fluid, but we have to pump it in order to remove the air bubbles. This rebuilt unit came with these bleed valves and hoses. I'll screw this in tight, and when we're ready to bleed, we'll put fluid in the unit. So the whole purpose of this is to fill this up with fluid inside the master cylinder with no air pockets. You have to push against the plunger to cycle both the fluid and the air out. I just use this punch as a tool and press against the wall. You're going to open up the valve a little bit. Now we push. Then when I let go, it's going to suck fluid in. So again, I repeat the process. You push. And then the rebound, it sucks the fluid in. We just close off this valve and we're done.
After the new brake master cylinder was primed with new brake fluid, we mounted the cylinder to the brake booster. We then went about fitting the brake line flare nuts to the master cylinder. A crowfoot adapter was used to ease installation. A new clutch slave cylinder was installed as well. With the side motor mount being detached, we replaced the front motor mount. Using a hydraulic jack to support the engine, the front mount was easy to remove and replace with a new one. The engine and transmission subframe crossmember showed signs of rust and deterioration, so we decided to replace it with one from a 3000 GT at the salvage yard. We cleaned up the donor crossmember and gave it a couple coats of rust prevention paint. Here's the crossmember installed on the subframe. We cleaned up and reinstalled the original starter motor back onto the engine block. When we bled the brake lines of air, we discovered a brake line corrosion leak by the right rear passenger side wheel well. We decided to cut out the leaking line and patch in a new one. Using a tube bending tool to shape and form the new clutch tube and a tube cutting tool to cut the tube line to length, we were able to make a new tube that closely matched the cutout leaking line. Connecting the end of the new line with the existing brake line was done with brass compression fittings. After the connections were completed and tested for leaks, leftover rubber hoses were used as friction insulators and held in place using tie straps. Now to the AC system. A simple R12 to 134 retrofit kit was purchased with R134 quick connect fittings. They're designed to screw onto the existing R12 high and low pressure quick connect service ports. The AC accumulator was replaced and the compressor drained of its mineral-based oil through a drain port. Since ester oil is compatible with both R12 mineral-based oil and R134A refrigerant, ester oil is the most commonly recommended lubricant with a R12 to 134A conversion. The original AC condenser, being made of aluminum, showed a lot of oxidation in its cooling fins, so we decided to replace it too. 3000 GT AC system is spec'd to hold 7 ounces of refrigerant oil. We added 6 ounces to the compressor and figured 1 ounce of residual oil in the evaporator and lines. After all the AC components were installed, connected, and free of any outside moisture, we pulled the vacuum for over 30 minutes and then let it sit to see if the vacuum would hold. As you can see, the high pressure gauge is pegged to the stop and the low pressure gauge is holding steady around negative 28 to 29 psi, so the system was ready for charging. While waiting for any vacuum leak to reveal itself around 20 minutes, we reinstalled the side motor mount. With the vacuum holding steady, we decided to introduce some Freon. The vacuum in the system will draw in almost a full can of Freon, which will show on the gauges as approximately 70 psi in both the low and high pressure sides. When both the low and high pressure gauges stabilize, no additional Freon could be added until the engine was started and the compressor engaged. But before we can start the engine to engage the compressor, we had to install the new radiator with new upper and lower hoses and a new thermostat. When replacing the thermostat with a new one, always replace the rubber gasket, even if it looks okay. We wire brush the oxidation off the hose contact surfaces to ensure a good leak-free seal with the new hose. The temperature sensors from the old radiator were transferred to the new radiator with new O-rings coated with dielectric grease. The radiator and AC condenser fans were then mounted along with the new upper and lower hoses. Everything fit perfectly since we purchased the OEM Denso radiator. The radiator was then mounted into the engine compartment, the hoses attached along with the electrical connectors. We wire brushed off the rust buildup on the exhaust manifold shield and gave it a couple coats of heat-resistant aluminum paint. Afterwards, the shield was mounted onto the exhaust manifold. Almost ready to start the car. The final step was to add coolant to the system. We used our spill-free funnel and poured in around 1.5 gallons of new coolant into the system. The battery base plate was installed with the battery, the air hose connected to the throttle body, and the filter box fitted onto the air filter box. The car started right up at the first try. First thing we wanted to get out of the way was completing the recharge of the AC system. The capacity of this AC system was around 24 ounces, which translated to 2 cans. Since this is a R12 system, the maximum high side pressure we saw was around 135 psi, as opposed to a R134A high pressure compressor that would be around 180 psi or more. As you can see, the downpipe exhaust needs to be replaced, and we'll be doing that in an upcoming video. Hope you enjoyed this video episode. There's still a lot more work to be done. Please give us a thumbs up and subscribe. Thanks for watching.